Hello everyone. Have you ever seen this concept called covariance or contravariance? Or to put it very bluntly, have you ever seen something like in associated with some kind of generic type? Have you seen out associated to a certain generic type? And have you wondered what these keywords mean, in and out? If you are struggling with in, out, covariance, contravariance, invariance, then this video is for you. Alright, for this video I've decided to create an application at the same time with you, a small software that we're going to use to understand how in and out works and what this whole thing about covariance is. Now, in a nutshell, what we want to do is we want to create a generic type that we can reuse to create other instances that have certain restrictions and not others. The normal types and the normal generic types of Java and of Kotlin are invariant. And this is a difficult concept to grasp, but essentially what it means is that when we are creating classes that use generics, we have to give something to the compiler to let it understand what are the variations in our generic types. Okay, but this is complicated stuff to explain in words, so this is why we're going to jump into our example, which is not built yet, and we're going to build it from the beginning, and I'm going to try to explain some minor details that might come up. Now, first things first, I need to introduce you to my project. This is A Suitable Nice Guy in a Suitable Age Group Forever. This project is located in my GitHub repo, and to save you the hassle of having to spell it out for you, the link to this repository is in the description to this video. Have a look at it and have a look at it for more information or more details or anything that you further want to know. And yeah, and of course, leave a comment. But we're not done with the video yet. We barely just started, so let's jump right into it. Let's now just create our project. In my repository, this one is specifically made to share knowledge. So every single module, you might call it, is really loose, and I'm mostly using Gradle, and I'm not creating any sort of hierarchy between the different modules. So they are really lost together. You could open these different projects separately or just open the main folder. Okay, let's just create the project for now. So let's create not new here, but we're going to go to File, and in File, we're going to create a new project, and we're going to call it Drinks Manager. All right, we call it Drinks Manager, and if you look at where this is being created, it's being created in YouTube sessions, long videos, Drinks Manager, which is exactly where we want it to be created. We select Kotlin, we select build system Gradle, because Gradle is just cool, and we use the Gradle DSL for Kotlin. And we add a sample code just to get our entry point and get us really quickly started to the project we want to make. So let's just create it. There we go. We have it. IntelliJ opens us this really nice pop-up window. I don't need it because we have it right over here. What I usually do, I just go here to settings, double click on it. And every time I do that, somehow IntelliJ opens another pop-up to add files to Git. I just say add because I want all of them in my repo. Of course, I'm going to commit when we are done with this project. I'm going to commit everything to our Git repository. And here we have it. But it did link the project already for me, so we can already continue with our program. Now, main, we can delete everything we have about main. And let me tell you about the example that we're going to have a look at it. In our example, this is something that I planned out. It doesn't mean that in reality we face this problem in the drinks factory, but I've imagined a drinks factory where we need different services, and the different services are going to be needed for different kind of products that we're going to make. And these products are going to have as an input parameter drinks, and as an output parameter, we're going to have boxes. We're going to have different boxes, and these are the products. Essentially, we're going to have a hierarchy of 3 subsets of boxes, and we're going to have a hierarchy of 3 subsets of drinks distributed with different types of hierarchy. So one drink that we can have is just the drink at the top, and then we can have warm drinks and cold drinks, and then from here onwards we can have tea and coffee, and we can have an orange juice and a lemonade. For the boxes, we're going to have a box, and then two different boxes, a plastic box and a cardboard box. And for the plastic box, we're going to have a deluxe edition. And for the cardboard box, we're going to have a family edition. So having said this, let's create our classes. So this should be very straightforward. Open class. What we said we wanted a drink. We want an open class for warm drinks. And this is going to be a drink. We also want, it's not warm. We also want an open class cold drink. And we also want open class tea drink, which is going to be a warm drink. We also want open class coffee drink, which is going to be a warm drink. We also want lemonade, which is going to be a cold drink. We also want orange juice, which is going to be a cold drink. If you've noticed, I'm kind of struggling between staying in English when I've lived for so long in the Netherlands. So the Dutch terms come in just as fast as English terms, so I get a bit confused. But yeah, so here we have a drink, a warm drink, a cold drink, tea drinks and coffee drinks, which are warm drinks, lemonade and orange juices, which are cold drinks. Okay, so now we need the boxes. We create a box, and then we create a cardboard box, which is a box, of course, and then we create a plastic box, which is a box. And then we create the deluxe, or in this case, let's create first a family box, which is going to be a cardboard box. And then we're going to create a deluxe box, which is a plastic box. So just finish it up here. All right, so now we have the whole hierarchy. We've got the whole polymorphism that we need to start explaining this situation. So we need to create a generic type, something that we can reuse to create different instances of what we want to do. So let's create a service, and we'll call it a drinks service, which is going to have as parameterized types. It's going to have a drink, which is going to be a drink, and it's going to have a box, which is going to be a box. Now, in Kotlin, if you are familiar with how Kotlin should work, we are not supposed to use mutable types. We are supposed to use as much as possible immutability. What I'm going to do is something very simple, and it is just something to show you also how do covariant, variant, and contravariant types work. So we have a database. We're going to start it by lazy. Also something interesting about the Kotlin language. We're going to use a UID as an identifier, and we're going to use a drink. Okay, because what we want to do here, we want to store our drinks, and because we want to simulate sending our drinks to a service. So what we do, we create a send drink, and in the send drink, we're going to accept as a parameter drink, and we're going to say that this was going to be database UID.randomuid is going to be that drink. Okay, it doesn't really like, but that's probably because we didn't do something like this, which I don't know. We could do it just like a normal function with curly brackets, but this is kind of beautiful, so we do it that way. Another thing that we want to do, we want to get the boxes. So get box. When we got the box, we're going to first need to create the box with the drink, and then get the drink out of the database. So let's do that. But for that, of course, we have the drink, we have the box, but in generic terms, we don't know which kind of box we're going to get. So for that, we can have an input, as an input, a create box function, which is going to be something that accepts a drink, and it's going to return a box. And this one is just going to be, the create box, which we're going to call with the first element of with the last element of the database. So it's going to be database dot keys last, and this is going to create the box with the last parameter. Of course, IntelliJ is complaining now because when we get things out of a hash map like this, we can end up getting a null. And the reason we are getting a null is because drink can be anything. We're not specifying anywhere that drink is a nullable or a non-nullable value. So in this case, we can just say require not null. For example, I find this more elegant than to use 2 exclamation marks. Be my guest to do whatever you want. In this case, it's not really mandatory. And what we want to do, we actually do not want to get it this way out of the database. We actually want to remove it. So we want to remove the last key from the database. Yes. So now we've created a box, and we have these services. So let's create. So now we have everything generic. We're still not using in and out, but we can create the services that we want to create. So let's just create val. Let's create, for example, a lemonade service, which is going to be a drink service with a lemonade, and we're going to put on the output just a box. And in the same way, we're going to create a coffee service that is going to use an input parameterized type, and it's going to be a coffee, and an output parameterized type is going to be a box. Okay, now we have coffee, we have lemonade, we have a box. This is all fine. But let's now create a function called monitor. And what do we want to do? We want to monitor our service. So instead of monitor, let's just call it check service state. Okay, so we have a service state, and what do we want? We want to check a drink service state. And then here we know that it's a drink service, and we know that we all want a drink, and we know that we want a box. Right. All good, everything compiles, not an issue, and if we run it, we shouldn't run into any single problem. We do, but that's because, of course. Now we should be able to run main. Do it. There we go. So now we just run main. And of course, now we have no issues with what we want to do right now. We want to be able to send a drink. So now we send a drink, and the drink is going to be a lemonade. And then we also want to get the box. And to get the box, we're just going to say, all right, we have created a drink service with a box. We can say a family box, and we can say, okay, let's get our lemonade. And the family box will need to get a lemonade. Will it need a lemonade? Probably just a drink, actually. So we can fix that. We can put here a drink. Because, you know, it is a box anyways. But, you know, let's make it a family box anyways. Let's make sure that it's a family box. And for the coffee drink, because we are software developers, we love our coffee. We love our coffee grinders. So that's kind of why I did this. Then we go coffee service, we send a drink, we send a deluxe coffee, and then we go and we go to coffee service, and then we get a box with a deluxe by returning a deluxe box and the coffee in it, which again, for the deluxe box, we can have anything we want. We can have a coffee drink, but we actually should be getting anything. So just a drink. Okay. No problem yet. We're still doing everything we can do with our services, not an issue, but we want to check the service state. And when we want to check the service state, we should be able to say, okay, check service state, lemonade service, and we want to check the service state of the coffee service. The implementation of the actual service state is not really important for this matter. It's just that if we want to use this generically, it's not possible because the compiler doesn't really understand the relationship between this type and this type. This type here is drink service, which is specifically typed with lemonade and family box. The other one is just a drink box, and this one is a coffee drink in deluxe box. So the compiler has no idea how to work around with these. But what we can do to try to fix this problem is to to say that drink is an input, is on the inside, and box is on the outside. Okay, so, but we're still not solving anything because this is still failing. And now we have more fails everywhere. All right, let's first fix these issues. The first thing, let's remove this warning because, if you don't have input parameters and you just have an open class, you really don't need to specify the default constructor. The other thing is this val database. What what IntelliJ is complaining about right now is that the type parameter drink is declared as in, but occurs in invariant position in type Kotlin collections hash map. If we jump into the hash map, we're going to see that all of these are invariant. What I mean with invariant, it's just the normal way that we have of declaring generic types, and that is with no keyword in them. There's no modifier. This what we see here is the point that I've seen in many other projects where developers usually do without knowing what the alternatives are. They would try to fix this error here specifically by using casts and subcasts and uppercasts and recreating the instance with the same parameters but a different type. All of these tricks simply because they were not familiar with this, and this kind of stuff is quite different. In Java it's a bit more complicated, but it's exactly the same principle. Of course, the way that this is being done in Java is with the wildcard question with a question mark. And that's not so beautiful as we can see it here in Kotlin. Anyways, I'm going to show you later the way to do this with Java and the way this is normally done in Java. But for now, let's just stick to Kotlin and see how can we fix this. Well, we know that when we are here inside drink service, we don't really care about what types the database have. So here we can just say that we accept any drink. Here we have something difficult to understand, and that is that the IntelliJ says type parameter drink is declared as in, but occurs in out position in type drink box. So we have to think about the type as the function. So this function, this is not the function, this is the type of the function. And what that means is that drink sits on the output of the function. So the way it understands is that we have here this function, and this function is part of drink service. This in refers to drink service. This out refers to drink service. Okay, so if that is so, think about it like this. Function is to drink service an input. So if the function is an input, the input of the function has to be the output of the getBox. If you think about it, the output of something from getBox ends up being the input of the function, but it remains as the out of the getBox. So drink is really on the out of this function. Whereas box is the output of the function of the function that we pass through here, but that out is this out, which can then be used as an input of the function. Another way to think about it is that whatever is here is the out, whatever is here is the in, because they swap positions. If you put in a function, the out is the in and the in is the out. You can also think about it that way. One thing that IntelliJ suggests to do is something that nobody in the world of Kotlin suggests to do. I've made a film about who mentions that the usage of UnsafeVariance is not recommended, and the name UnsafeVariance is made this long precisely to discourage people of using it. So we're not going to use UnsafeVariance. We're going to use the same trick that we used above, And that's going to be that box is going to be actually a box, and drink is going to be a drink. So not the generic types.
We're going to look at an example that uses a concrete class. In production environments, we will find mostly examples with abstract classes and abstractions and different types. At the end of this video, I will explain further and show briefly an example with abstract classes. With one concrete class, we avoid having to define multiple types, and therefore we create a simpler example to understand. I also had to make a correction to the getBox function.
Now everything compiles here, but here we still have issues. And the issues are a bit confusing now, because now we're going to go into the details of what is in and what is out. What do these modifiers do? These keywords, what do they represent in Kotlin? Why are these keywords important, and how can they change the way we program? Okay, so we were almost there. We were almost going to use our drink service and check their statuses, but we couldn't because we are still stuck with something that doesn't work. Let's start with from left to right. So on the left side, we have the in. We can read this on a different way. If we are creating a drink service that allows drinks, any drink, then we should only accept services here that accept any drink. So that means that drink services that accept lemonades, coffee drinks only are vetoed out. We cannot have them because this doesn't make sense to the compiler. But we could, for example, say, hey, just accept lemonades. Lemonade now compiles. But we have the problem with coffee. In a generic way, we can't fix this because this bit, the lemonade service, is already the lowest subclass of the hierarchy. We've already said that the lemonade service only sends lemonades, and there it will create a family box. Coffee service, on the other hand, sends coffees, and from that it makes a deluxe box. But hold on. Before fixing this side, how about having a look at box? Now, box is an output parameter. So that means that if I say that this service gives out a box, it just gives out a box. That means that on the output, I will have a box. But I'm already defining here that all of those boxes will be family boxes. So on the output, this box can be whatever I define it to be in the service. Here in the service, it doesn't matter how I use box, because everything that a box can do is what everything a family box can do, and it's everything that a deluxe box can do. On the drink side, we don't have that. A lemonade is not something that will be able to, that has the same properties as a coffee drink. So here, they will conflict. The use case for this is that we need a function that can do things in common. And to do things in common with an in and out parameter is a bit difficult. The drinks in this company are being processed in different ways. We have cold drinks on one hand, and we have warm drinks on the other hand. We don't want to check service states. What we want to do is, for the warm drinks, we want to check the resistance state. And for the cold drinks, we want to check the cooler state. And we're going to check for the drink service. We're going to check for cold drinks and box. And here we're going to check for warm drinks. We still have another issue, and the issue is that we've created a service that it specifically creates only lemonades, and another service that specifically only creates coffees. Our drink service stores drinks separately, and per drink it makes something. If we have a machine that warms things up, isn't it more logical to have that machine heat up whatever drink? What we need is a service for one warm machine and a service for another warm machine, because both are the same. Coffee heats up pretty much in the same way that tea does. the machines have a thermostat, both the warming and the cooling system. They have to be a bit different because one cools out the temperature and the other makes the temperature warmer. So we do not really want a lemonade service or a coffee service. We actually want a cold drinks service. And we want it to be cold drink. We want to send a lemonade. We want to send an orange juice. We want to get boxes. 2 of them actually. And then we want to have a warm drinks service. And it's going to be a warm drink. And then we're going to send a coffee drink. We're going to send a tea drink. Get a box, get a box. Right. Now we check the resistance state and we check the cooler state. We check the cold drink service here and we check the resistance state in the warm drink service. Right off the bat, they work. But we're still not seeing the potential of the in keyword. Because now, to manage these services, what we want to do, we want another service that maybe we want another service because our company is now testing a new device that has both functionalities. It can warm and it can cool drinks. So we're going to call this a generic drinks service. And the generic drink service is going to be a drink service that accepts any drink, and it will wrap everything up. It's just cardboard box. We just want a cardboard box for this one. Okay. For which of these do you think we could test the resistance state and the cooler state? Do you think we need to call it twice? Could we call it with just one or the other? Do we need to make another method that checks the resistance and the cooler state? Let's find out. Let's check the resistance state and try to check the resistance state of the generic drink service. Look at that. And let's check the cooler state of the generic drink service. It compiles. Not only it compiles, it runs, and it does not fail. What did just happen? Well, as I explained before, when we make these methods, what we are saying here in a way that everybody understands, by checking a service that will accept a warm drink and produces boxes. Why is this not an issue with sending a service, with putting through a service that accepts any drink? Well, because here, if we are only putting warm drinks, what's wrong with that? The service accepts drinks anyways, it's a generic service. So what we are doing here, we're being contravariant, because actually it doesn't really matter what sort of drink, because the only thing that matters here is that the service accepts warm drinks. So a service that accepts drinks also accepts a warm drink. Because a warm drink is a drink. And this is what being contravariant is about. It's the same as saying that a warm drink is a drink. And that is valid also for the cold drinks. You know, we have a service that accepts any drink. That means it will always accept also a cold drink. So for this service, I will only send cold drinks to a service that accepts any drink. And that is contravariance. The parameterized type on the right makes this generic type an out. What does that mean? Well, we are accepting a service that accepts any drink, and therefore a warm drink, but we are also accepting a service that will put out a box. The out is already implemented when we get here. we're not going to change anything to that service. We're not going to add something that the service does not handle. Whatever we push out of the service will be a box. But that's as far we're going to go. We're not going to push anything into the service. It's just a box. So here, it doesn't matter to us what kind of box is it. It says here, we accept the box. We've said that a deluxe box is a plastic box. So what do you think will happen if I say here a deluxe box? Something fails. And what does fail? Well, definitely not the cold drink service, but the generic service will fail. And the reason is that, do you remember what we've given to the generic service? Which type was the generic service? If you recall correctly, the generic service had a very specific type. It was a cardboard box. Now, a cardboard box is not a deluxe box. So in that case, what that means is that this function is accepting a service that will put out deluxe boxes. But a cardboard box is not a deluxe box. A cardboard box in its next upper type is a box. So cardboard type and deluxe box would never match. And that's what we see here. So this can only be a box. So we've created two different functions that can now be used with the right services that we've intended them to be used for. In this example, we've created two services that should only be applied to machines that warm up the temperature, to heaters, and the other one that can only be applied to coolers. And we've made two methods, one that's going to check the resistance of the heaters, and the other one that's going to check the state of the coolers for the freezing machines. But now we have a generic machine that can be a cooler and a warmer. But we can still check its resistance and we can still check the cooler state because we've used this. Now, you might be thinking, yeah, but still, it looks to me that this could have been done with input without the in and out keyword. If you're convinced of that, I will remove it for you. And as you can see, it doesn't work that way because, again, if we remove in and out, we are making these invariant types. It's in the name. Whatever combination we give here in these services, it won't work because only the matching combination will work. And we can check that right over here. We know that the warm drink service is now a warm drink in the deluxe box, and the resistance state says that it only accepts warm drink and boxes. So we're going to say deluxe box. There you go. Now it compiles. But of course, this isn't what we want. We want to be able to compile all of this, and we want to be able to run our program, and we want to not use these constant casts and recasts, and we don't want that. All right, so this is what we have for Kotlin. It will be interesting now to have a quick look at memory lane and a bit go back to see how this was implemented in Java. So back in the day, we would have a Java class, and in this Java class, we would have to say, all right, let's call it just drinks manager. There's our class, drinks manager. And we're going to create a main function. And now, thing is, I'm almost sure that I can use drink. Can I use drink? New drink. Can I use that? Yeah, I can. Okay. So I can use the hierarchy that I've created in Kotlin, which is great because I don't have the hassle of doing this all over again. But what I can do now, before I do anything, is just copy this code. Actually, the code that I need to copy is the drink service. So we'll create a class, a Java class, and we're going to call it drinks service. And this drink service, of course, has the same name, so we're going to call it drink services Java. Let's do it that way. And our drink service Java is going to have two types. It's going to have, as we said, drink, and it's going to have box. Okay, so far so good. In our main function, we're going to say all of this. Again, I'm just trying to save as much energy as possible with this conversion to Java. Let's see, we can have a resistant state and a cooler state. Let's just copy this literally into it, and let's copy it to here and make these static functions. So public void static, and then public void static. Oh, void static. All right. There we have this, and then of course we don't want this, we want this. And we also want this to be drink services Java. Okay, and here we want the same thing, we want this out, and we want this to be here. So static void, okay. Okay, so now we have the check resistant, check cooler state, we've got the drink services Java going on, and what we need to do, we're going to have to, probably the best way is just to copy this and copy this into the main function. And now the good thing about current Java versions is that they do have var. If you use Lombok, you can really make a number about this. All right, but Java, no matter how much it changes, it remains the same thing all the time. You need to use new and new and new, and you also need semicolons everywhere because that's cool. And I'm really not done yet. Okay, like this, and all right, so this one, okay. Good, we want new here, we also want new here, and we also want new here, and new, and everything is new and fantastic in Java. All right, so the first thing, the easiest ones are these ones. This is going to be a drink. And again, we can private, final. This is going to be a hash map of UID and drink. It's going to be database, and it's going to be a new hash map like this, using the diamond notation. And yeah, so then we can say that we want to add this value to the database. It's going to be put UID, random UID, and then the drink. There. I still remember this stuff. It's always there, huh? Always there. And now we are not ready yet. We still need to do these are the lambdas that we need to make. So getBox is not like this. This is not how lambdas work in Java. How they work in Java is like this. If I recall correctly, there's no such thing as an it. The getBox is a drink. Yeah, it will have to be a drink. In this case, it has to be a cold drink. And the family box will have to accept a cold drink. Those, all of these are going to have to be like this. So this is kind of what it should be. Lambda parameter, of course. I'm going to create a box now here, and this is not what it should be. What I want to do, I want to get a consumer. And I think that if it is a consumer of type drink, not drink service, but drink, or actually drink, it should work. Yeah, and oh yeah, so then we can just replace it. Yeah, this is better. Of course, yes. Okay, so this is all good. For the other ones, we just want to, I'm just going to copy paste it, and then, nice one, deluxe new, and then here also like this. Okay, and here we want new, and we want new. Should be almost there. It's just that when I use this one, it goes right there. And what does it say? Exactly. So now what we have here is that we are, yeah, it's also not okay because we want this one and this one to be all the same. Here we have, yeah, so now this is failing, but this is failing because the first parameter of method checkers from drink swarm box is not a deluxe box. So coming back to this class, what we see here is that we have not yet restricted what kind of types drink and box can be. In Java, you can only do this and say that a drink type can only be a drink and a box type can only be a box. But we don't really have a way to define in Java what is covariant or what is contravariant in the class. The way we used to do this in Java was to go here to the methods that where we are passing these services as parameters and saying that for the warm drink, that this is going to be a super type of warm drink, and box is going to be, we're going to accept all super types of warm drinks, and we're going to accept all subtypes of boxes. So essentially, by mixing these two, we are creating exactly what we already created in Kotlin. And then here we just have to say the same thing, that we accept any supertypes of cold drinks and that we accept any subtypes of boxes. Now, here we have something completely different in Java and something completely different in Kotlin that attempts to solve the same problem. In Kotlin, we are defining the input and output, thus the contravariant and covariant types, inside the class definition. So our generic type already knows that this parameter, this parameterized type, is an in type. So it has modifier in, and that means that we can only use it as an input parameter, and we are losing the restriction of only being able to be passed around and accepted as a supertype, thus contravariant. In the opposite way, the same thing happens to the box, which now it's on a covariant type, and that means that in the drinks service definition, we are saying that the box is an output parameter, and therefore it is only used in the output side of functions, so the return type of functions, and that because that is the out of the functions, and this modifier is making sure that in the output we can accept anything that is a box. So all subclasses of boxes will be accepted as the output parameter. But in Java, the approach is a bit different. We extend, we allow here types to be drink and any other subtypes of drink. We allow box to be a box or any subtype of box. We accept that here. But if we are using in a hierarchical way, all methods need to be created with this definition of an input parameter, where we specify per method if we want our types to be covariant or if we want our types to be contravariant. This whole thing here and this whole thing here seems like a repetition, something that we are avoiding doing this way in Kotlin. And to be fair, when you look at this, I know exactly what drink is, I know exactly what box is, I know what this generic type is, and I know what this generic type is. I know it can only be drinks, and I know it can only be an input. And I know that this one can only be boxes, and I know it can only be an output. Contravariant and covariant. I know everything when I read this class. When it comes to Java, the option does not lie in the class. Instead, it lies in the definition of the methods that we are going to use. Do you remember when we were using that annotation here, the example I showed you with that annotation? Well, that's kind of the only alternative if you want to keep using these types, something that Java doesn't need. The amount of code that we have been using in Kotlin is substantially lower than what we have in Java. And for the Java code, I just reused the types that I've already created in Kotlin. And it still works. And if we still run this main function, Yes, okay, so now it works. So I guess when you come from, when you work massively with Maven, you kind of miss these things. Indeed, so the Java files, by the default, in the default configuration, they really have to be in a Java folder. So now they run, and as you can see, there's no errors. So there's no runtime errors with this code. Everything is being called, and it works perfectly.
As I mentioned in the beginning of this video, there is an example using abstract classes next to this example that we've just seen in this video. The example with abstract classes is more similar to what we usually find in production environments. Have a look at it. In this example, we are essentially creating different classes for the different goals we had. So every service will have a new type, every different service, and then we can make instances of it, which is most likely what we actually need in production. And just to reiterate the fact that we have used a concrete example, a concrete classes example, simply because it's easier to show and to interpret what actually in and out mean and what do these modifiers do to generic types.
What have we checked so far? So far, we've checked quite a few things. What covariance is, what contravariance is. We have here a simple example on where it would be possible to use these concepts. I have to say, in my professional experience, I hardly ever saw a massive usage or even a special case where these could be in use. People don't really use these things in Java. I've seen a few of them where yes, but most of the times these are relationships between types. These kind of generics, very sophisticated way of using generics, isn't something I come across very often. And I'm sure that if you are a Java developer or a Java certified professional, just as I am, you might not be, or maybe you are disappointed that you didn't use this very often, or maybe I don't know. I mean, this is something that has a huge potential. And of course, the example with Kotlin is much more elegant. We have created a class with very, very little amount of code. We've simulated a database. We've used covariance, contravariance, which essentially means that we have a drink service that accepts drinks as input parameters. We specify as the input parameter the subclass that we can use, and it means that when we pass this thing around, the compiler will understand drink service to be of the same kind when this contravariant type sits between the subtype that we defined up until the upper class. So it goes in a contravariant way, and it accepts a covariant type, which is a box that can be any kind of box and will only be used as a return parameter in our class in its functions. I think this is a great addition that Kotlin has. I think this is something that is quite overlooked in Kotlin, and this is the reason why I decided to make a third or fourth or fifth, I don't know, another video about covariance, but this time with live code, so that you could go with me and so that we could go together and learn a bit about these things in Kotlin. I will now push the code and see if you, have a look at it, have a look at the code, check it out. Again, if you want to find out where the project lies, please, I suggest you check out the description. You can see in the video also where it is. I can also show you in the command line. Git remote show origin. That's it. So this is the URL for the repository, and you can have a look at it. And I hope you enjoy this. I hope you've learned something today. I've definitely learned a lot and had a lot of fun doing this video for you people. It's been great having you here. I know this video is not perfect, and I want to make them better and better and better, but this time the learning curve was so sharp. It's a bit late, and appreciate that you've been watching the previous videos, and I hope to see you on the next video. Until then, don't forget to subscribe, give a like to this video if you've enjoyed this video. As I usually say, Keep it graceful and stay sharp.
Thank you for watching.